Welcome. In today's lesson, we're going to learn about the if statement. It's an immensely powerful tool that, although simple, opens up all the avenues of computing that we are going to be using. Now, looking at our bit of code here, it's demonstrating the concept of something called sequence, i.e., the first thing you do is kettle being boiled, then putting the tea in a mug, pouring the boiled water into a mug, remove the tea bag, add milk, add 2 teaspoons. Now, obviously, you may not take tea this way. And in fact, you may not even drink tea. And spoiler, I'm much more of a coffee man myself. But this is just to prove the principle of sequence. If I run this, it will do it in this particular order. And it doesn't matter how many times I want to run this, it will always do the same things in the same order. Now, you yourself may be thinking, do you know what? Actually, I want some choice here. I want to be able to pick some different options that are going on here. In fact, to do that, we're going to do something called a if or else statement. But before we get to that, I just want you to draw your attention to down here, we have a new cheat sheet. And this cheat sheet, it's all to do with the if and else, and indeed something called the ELIF statement, and the logical operators you need to use to do that successfully. Okay, so how do we use if or else here? Well, let's say, for instance, maybe you want milk, maybe you don't want milk. Here's what we'll do. We'll write down if. If is the statement that we're going to use. But actually, we need to check against something. So before that, we're probably going to need to take in as an input from the user whether they want milk or not. So why don't I have a new variable here, milk, equals input, and we'll ask the question, do you want milk? Do we remember what data type milk will be taken in as? That's right, a string. I'll just make the assumption that it's going to be yes, or a Y or an N, in fact. Let's make life easy on myself. So I'll say if milk is equal to Y, so if the response is Y, then we should add milk. Okay, there's some syntax errors that were going on here, and a very important concept that's subtle, but it's very important to understand. We use this equal here. We use it for something called assignment. That means that we're assigning whatever this is into this variable. So we're taking that value and assigning it into memory. If you look here, I'm saying take the Y and assign it into memory. That's not what I want to do. I want to compare. I want to say, is the thing in memory the same as Y? I want to check them. And to do comparisons, it's not a single equals, it's a double equals. Double equals compares two different values. And if they are the same, i.e. they're a match, it will return true. And if it won't, it returns false. So here, if it returns true, it means it will run this thing here. At the end of an if statement, we need to put a colon. Colon basically saying this is where the if statement's ended. Now, what you might see down here is that there's a bit of an issue that's going on here. Well, we need to learn about another concept called indenting. Now, indenting means basically just things being moved in slightly. And indenting is a really good idea. You should use it to make your code more readable. But here it's not just a good idea. It is, again, part of the syntax. And if you don't indent your code, it just simply won't work. We should indent the code that we want to trigger if this is true. So we want that to happen. So we say if it's true, and I just pressed the space bar, you're welcome to tab if you want. Actually, it really doesn't matter in this case, but I'm going to give a single space bar in. Well, what happens if it isn't yes? I don't know if you remember from earlier, I was saying it's an if else statement. So I can say else. Now, do you see here that actually now I'm indenting that else? Don't want to do that. The if and the else need to be at the same place. So I'm going to come back, else, and I have to end this with a colon. And what do you want to say? We want to say if this is the case, print no milk for you. Oops, and if only I could type correctly, my life would be so much easier. Okay, shall we run that and see what happens? Also, bring yourself to attention that the print here, That's back in line here. The only bits that need to be indented were the bits that were associated with this if and else. Okay, let's run it. So we get down to here, the kettle boiled, done all this, and here's where it's asked me the question. If I type in Y, it should then run this line here, add milk. So let's see. Oh, you can see here, actually, that's not going to work either, because what is milk? It's a string. So I need to put string outside here. And now if I run it, much happier with us, fingers crossed, and we say yes, and it says add milk, and add the 2 teaspoons happen otherwise. Question, what happens if I put capital Y? What do you think is going to happen if I put capital Y? Yeah, that's right. Essentially, anything that isn't lowercase y is going to trigger that no milk for you. So if I run it, it says no milk for you. So it's not super precise, but it's on the way there. What about this? Not everybody's going to want to have sugar in their tea. So let's talk about some other logical operators. We've got this one, which is equal. So you could say yes or no. But maybe a more suitable question would be, remember, I need to go to the beginning, sugar, and maybe how many sugars they want. So we go input, how many sugars do you want? Question mark. What data type do you suppose that's going to be? Now, I could take it in as a string, but I want to say, is it greater than a certain number? So I want to do a logical comparison. So I need it to be an int. So int will take in the number of sugars. Okay, what do I want to do with this? Well, I'm going to say if sugar, so there's the number of sugars they wanted, is what, greater than 1, then we can say, we can print, remember we want to indent again, I'm going to indent by 1, print 6, you want, or maybe I should say 5 to make that logic consistently, you want sugars. So that will say you want 1, 2, 3, whatever number of sugars. Remember, that's going to be an int. So I need to cast that now as a string for us to print. And if it's not that, if it's not 1 or more, then I want to say print 6, you do not want sugar. Now, there's actually a deliberate mistake in it, and I guess a lot of you will spot it. I'm going to run this. I'm going to say, yes, I want milk, and I want 4 sugars. I'm going to need to see the dentist pretty soon. Brilliant. Works perfectly. What happens if I run it and I want 1 sugar? What do you think is going to happen? So I want 1 sugar. What do you think is going to happen? So I'm going to type in 1. It's going to say, is 1 greater than 1? 1 is not greater than 1. Therefore, it says you do not want sugar. So let's talk about some of the other logical operators. That's greater than, but we also have greater than or equal to. So if I run it now, it's going to say yes, but this time when I say 1, it will say, is 1 greater than or equal to 1? Well, it is equal to, so it'll work for me there. Okie dokes. Just briefly, it's worth bringing your attention to. You can do other things. That's just less than, so that would only become true if it was less than or equal to was the other one. Okay, now we're into a we section, and what I would like you to do is solve this question. Underneath here, we can have a little read about it. It says, a student takes 3 tests. Each test is out of 20. So you're going to need to allow the student to enter each 3 test scores and think about the data type. Is that going to be a string or is that going to be an int? You need to add all the test scores together. And if the score is 36 or higher, okay, you need to output they've passed. Otherwise, you output they have failed. Cheat sheets will appear. Just want you to give it your best shot. Okay, how'd you get on? Hopefully, you're now in a position where you've tried some of this, and the first bit, hopefully successfully. So I'm going to go test 1 equals, input, please input test score. Now, of course, the limitation with this is that it'll be taking the input in as a string, and we want to be able to take it in as an int because that's going to allow us to add it together. Remember, if you add together strings, you aren't going to mathematically add them, you're going to concatenate them, you'd stick them together. So, and we'll have test 1, test 2, and test 3. Or maybe here I'll even say test score 1, test score 2, and test score 3. There we go. And then we'll say total score is equal to test 1 plus test 2 plus test 3. And so that's going to total up all our scores. Now what we care about is if total score, I'm going to put maybe a deliberate error and you spot it, is greater than 36, ending with a colon. Remember, we need to indent, so I've tabbed indent, that's fine. Print, you have passed. And then, remember, we need to be, the if and else needs to be in line. Else, colon, print, sorry, this time you have failed. Now, if I run this, for the most part, it's going to work, but it's got a serious logic error in it. So if I'm going to run this, I'll say, or let's say they did really well. They got 18 on each test. You have passed, right? That's what we're expecting. To get 36, you get 12 on each pass, 12 on each test, and that will give you 36. So we're hoping if we input 12, 12, and 12, but it's saying we haven't passed. We failed, even though we've got a score of 36. Can you see why that is? Yeah, that's right, because we've said if score is greater than 36, which in this case, it's not. So we can say greater than. By the way, I didn't like the syntax of that, so I'm going to put a couple of spaces in here. In fact, you can be like that. This is just syntax, but I thought it looked a bit clumsy the way it looked before. If we run it this time, it'll say, please input your score, and we'll say 12, 12, and 12. And this time, because we're hoping that's going to generate 36, is 36 greater or equal to 36? Yes, it is. And therefore, hopefully, you have passed. Okay, so we've made use of the if and else statement. And truthfully, just using if and else can take you a long way. However, sometimes you want something that's going to allow you more than just two outcomes. When you think about it, you've got a decision coming down and it can only go of one of two different directions. Sometimes you want to have 3 or 4 or however many. In fact, why don't we have a go at trying to tweak this? How about this? If we said that if we pick more than, say, 3 sugars, we can say, give a message saying, that's too much sugar. We're the nanny state, we're trying to take care of us. And we'll say, you can only have a maximum of 3. If you have between 1 and 3, you get 1 and 3. And if you ask for 0, you get 0. So you've got 3 different options. And to do that, we're going to use the command ELIF. Now, the way I want you to think about it is that you're going to need an if statement. And then you've got ELIF. It's like another if statement in there. And it's else if is what it's short for. And you could actually have as many ELIFs as you want. So you could have an if, an ELIF, another ELIF, another ELIF, another ELIF, and then an else. And that will give you, gosh, what was that? 5, 6 options. In this case, we just need the single one. So I'm going to say if sugar is greater than 3, so 4 or more, I'll say too much sugar. You can have 3. Oh, maybe like that because the rest is in numbers. And then now, instead of else, I'm going to knock that down. And I'll say ELIF sugar is greater than or equal to 1. And we'll say if that's the case, we want to go print. Oh, sugar! I could have used the original thing there. You can have plus stir sugar. Sugars. Now, if you remember, that was so that sugar was it's a int to convert it to a string to say it. And then actually the last else would do just fine for us. You do not want sugar. So we've got 3 different options. Greater than 3, you end up having 3. Equal to or greater than 1, but less than 3, you can have this. No, less than or equal to 3, because that's greater than 3. And then finally, if you don't want any, you get the else. So do you want milk? Yes. I want 10 sugars. Too much sugar, you can have 3. And I guess maybe the other test is if I do 3 would be an interesting test because it's right at the boundary. So I say yes, I want 3, and you can have 3 sugars. So that's if, ELIF, as many ELIFs as you want, and then else at the end. The way I like to think about it sometimes is like the if, ELIF, else sandwich. So with the sandwich, you need the if bread and the else bread, but you can have as many fillings as you want. You could have a sandwich that's just bread, so there's the if and the else, but you can just add in as many else ifs if you want in there. Okay, let's try and do one of these together. This is another we section, and we're looking at extending the test algorithm you wrote earlier, except this time you don't just have the 2 outcomes, 1 pass, 1 fail. Now we want to have 4 different outcomes. So we want to be able to have distinction if they got more than 48, merit if they got more than 42, or 42 or more, sorry, it's inclusive of the number, 36 if they got 36, a pass if they got 36 or more, otherwise fail. And you remember I said it's like an if, you want 4 outcomes, so you can do if, ELIF, ELIF, else. So I want to give you the opportunity to give this a try. Pause me, and let's see how you get on. Okay, guys, let's see how you did. To be honest, it's not a huge difference from this. What I would say is for the top if, now I'm going to make it, is it 48? And if it is 48, you say you have a distinction. Distinction, yep. And then remember now, we don't want to type the ELIF from here because that is indented. All the ELIFs and the else need to be in line with that top one. So ELIF, and this time I'm going to put the test in. So the total score, I'm going to go from top to bottom, so not randomly. I'll go the next one down. So the next one down would be 42. Remember, greater than or equal to, because if you got 42, it still counts as the grade. And is it a merit, I believe? Indented. I have to indent it in. I'm going to say you have a merit. And then I'm going to need another ELIF statement, because this time I need the one for pass. Again, that's not what you want. You want the ELIF to be in line with the other ifs and ELIFs, and it's greater than or equal to 36. And then we can say you have pass. You have a pass. Oops. Control P is not what I was looking for then. You have a pass, and else, sorry, this time you have failed. Let's test that. So we run it. The suitable test would be right at these boundaries. So typing 48. Oh, okay. And 0 and 0, you have a distinction. Good. When you do it, it's going to take some time for me to do it, but it's worth you testing at each of those that you've done those correctly. Testing 48, 42, 36, and probably at 35 on the other edge. Okay. We're now getting to the opportunity to do a U section. So it's your opportunity to demonstrate some of the learning you've just done. Underneath, you can see the thing you need to achieve. It says you need to be a different minimum height to ride rides at Disneyland Paris. You need to take in the user's height in meters. So think, is that going to be taking it as a string or as an int or a float? Okay. If they're 1.4 meters or higher, so if you're 1.4 meters, you can ride and you should then say you can ride the Indiana Jones ride. If you're 1.2 meters or higher, you can ride the Hyperspace Mountain ride. And if you're 1.07 meters or higher, you can run Big Thunder Mountain. And if you are smaller than that, then you can ride the Teacups. Best of luck. Pause me now. I hope that went well for you. We're going to be going on to the next section now. Okay, in the next piece of learning, we're going to explore a bit more thoroughly logical operators. So far we've seen if we can compare one a piece of data to another, we can do a logical test, and if it's true, it will trigger it, else it will pass on to the next thing. Or sometimes you want to stack these together. For instance, let's say traffic lights, when they go from red to green, why has that happened? Well, it could be because a pedestrian has pressed the button. Or it could be because a car has arrived and triggered it with its weight, or maybe a camera sensing it. Or it could be the right time in the period of the sequence of these lights. And so we're going to explore the logical operators of and or to combine logical tests together, and indeed make the use of something called nesting, which also allows us to combine if statements together. For this, I'm going to look at the example of a phone. Now, I imagine quite a few of you have a phone, and actually unlocking a phone these days can be as simple as just picking the phone up. Now, what I'm going to say is I'm going to have a new data type that's going to be introduced to you in this moment. I've kind of referenced it before. Whether something can be true or false is totally critical to the way that computers work, and that thing is called a Boolean. So I can say pick up, as in is the phone being picked up, and I'll say it's true. So in a Boolean, something's either true or false. So there's the data type of Boolean, like this. If I went like that and put speech marks around it, it would become what data type? That's right, that would be a string. And if it was a number, it could be an int or a float. But this one's a Boolean. It can only be true or false. So if I picked it up, it's true. And I'll say if pickup is equals, remember that's comparing to true, then we can say print phone has been unlocked. Okay, but this is not super exciting, but if I run it, it's going to pick up it's going to look at the variable here and see it's true, compare that and see if it is true, and if it's the case, then phone becomes unlocked, and you can see that the outcome's there. Let me point something out to you though. Every logical test, if it passes the test, it becomes true. And if it fails the test, it becomes false. So check this out. You don't actually need to do is equal true. You can say if pickup, because pickup's going to be true or false. You don't need to test if it's true. It is true or it is false. So if I run it here, you'll see the phone has been unlocked will work just the same. And if I change it to false, what do you think is going to happen? When I run this, what do you think the outcome is going to be? Should we see? Nothing happens. Well, technically stuff in the background happened. It looked at pickup. Pickup was stored as a variable as false. It said if false. So if it's false, then don't do it. Phone has been unlocked. So maybe what I need to do here is I'd say else print phone has not been unlocked. And now if I run it, it's going to give us a slightly more satisfactory outcome. Phone has not been unlocked. Now we know, unless you've got really poor security settings, just picking up the phone won't do it. Picking up the phone will then look at the next thing. So I could say inside this if statement, so it's being picked up, and I'll say if it's being picked up, if, how about face ID equals true, and you've picked it up is true, then we'll say if face ID, so if your face ID has triggered it, then you can say print phone has been unlocked. And I don't want it there anymore because I just want it to happen here. So let's explore what's happening for a second. To get to this line, both these things have to be true. In fact, you don't even need those brackets. We can just go like that, face ID. So should we run it? So because pickup, we did pick it up, true, and you did have your face ID true, the phone has been unlocked. So this is creating the function of something called an and. It's saying this must be true and this must be true, and therefore it will happen. If I change any of these to false, if I change face ID to false and I run it, what's going to happen? Well, it's going to say nothing. Why is it not going to trigger this else bit? Well, because that's the else for this thing here. So we need probably a bit of a smarter way of doing this. Let me show you. Because I want to combine these together, I can actually use a function called and. So I can say, and I want that to be in line with that one. If pickup and Face ID, so both of those are true, the phone has been unlocked. Otherwise, it's going to run. So I can say in here, the phone has not been unlocked because it's checking these two together and it's checking that one there. And actually, if you can look, it's a lot easier to read. So actually, using the AND command is a lot slicker than using nesting. Well, is Face ID the only way you could unlock a phone? No, right? You could use fingerprint. So I could do fingerprint is equal to true. So yes, you haven't picked it up and used your Face ID, but you have used a fingerprint. So we could say if the pickup is true and Face ID and fingerprint. Okay, this isn't quite doing what we want if you think about it. This would mean that the only way to unlock the phone is if you both picked it up and you had your Face ID and you had your fingerprint. What we want to do is we say these two together, either of these will do. Either of those being true will unlock it. So you'd say or. And now if I run it, it's saying phone has unlocked because pickup was true and Face ID wasn't true, but fingerprint was. So false or true makes true, and pickup and that makes true. Phone has been unlocked. So you're going to find ands, ors, something you're going to use a lot of. Nesting, don't feel free to use it. It's kind of an alternative to and. Sometimes it makes it actually easier to read depending how you structure it. Okay, so now we get to an opportunity to test out some of these new logical operator functions. And our problem here is going to be where we're going to take in a username and password and then either print access granted or say one of them was wrong. And we have to be quite careful about how we read this problem. It says storing variables. So we have to store username and password, both as strings. Then we ask the end user for their username. And then if it matches, then allow the password to be entered. So we need something to stop it. We don't want to ask the username and password at the beginning. You want to stop it before it gets there. If they get it right, the username and the password, then access is granted. Otherwise, you'd say wrong username or password. Right, give it a shot. Okay, how'd you get on? Hopefully the starting bit's not too bad. We'll store how about username? Username equals Bob. And then we'll say password. Whoops, I didn't put the equals in there. What is wrong with me, eh? Is password, is rocks, it's not password. And then we're going to want to take in their username. So uname equals input. Obviously, don't use username again. If you use username again, it would overwrite it with this, which is not what we want to do. Please enter, username, ... Now, we don't want to ask their password now, because if you remember, it said we wanted to be able to enter the username, and only if they get it correct can you go on to the password. So we'd say if uname, do you remember what comparison was? Yeah, double equals username. So if they match, then we'll say, then we'll ask them for the password. So p-word equals input, please, what am I doing here, honestly? Please enter password. Now, I want you to bear in mind then is that we can't really use username equals username and put them on the same line because underneath that, we have to wait for the password. So this is one of the cases where actually it's better to use nested. Not just better, I don't know how you'd achieve it otherwise. So if the password is also, equal to password, then print access granted. Now, that will hopefully work, but we also need to say wrong username. So we can say over here, else, so in line with the original if statement, print wrong username. Now this is actually or password. this has actually got a weakness. I don't know if you can spot what the weakness is. How about if I run it? So if I'm saying that if I put it in correctly, hopefully if I don't make mistakes, rocks, I'm saying Bob has allowed username to become username. They matches, so then it asks me for my password. If that matches, it gives me access granted. Okay. In what ways? So access granted works. I'm saying it's the wrong username is going to fail somewhere. Can you see where it's going to fail? So I'll show you somewhere it won't fail. If I give the wrong username, so gob, wrong username or password. So it's the last kind of permutation. It's if I get Bob right, and then if I get the username password wrong, rock. It doesn't do anything. And that's because it's never going to come down to this if statement, because this else, because it passed that if. So it went here. And then there's no else for this one. So what I'll need to do, and remember, the way of matching it up is it's got to be indented at the same place. In fact, I'm going to be a bit sneaky. I'm going to steal that. But I'll have to make sure that else, you see it's in line, and then that's indented in here. So that's where the indentation is totally critical, because they're the matching if and else. These are the matching if and else, which seems crazy because you've got this in between, but that's why indenting is so critical. So if we run it now, if I get the username right, but I get the password wrong, I don't know why, wrong username or password, works this time. Okay, this is another wee section, giving you the opportunity to practice some of the stuff we just discussed. You're going to want to use the logical operators of and or. And actually, in fact, I didn't mention it last time. There's also not, which you'll see on the screen, and there's a good chance you're going to want to use it. Now, if you read underneath here, there is asking you the question if you need to ask if it's a weekday or if it's a holiday. Now, this is all about whether you can get to lie in, stay in, or you need to go out to school or to work or whatever. So in this case, if they say, yes, it's a weekday, you then need to store true for weekday. And if it's false, if they said, no, it's not a weekday or not a holiday, then you need to store that as if they said N, you have to store that as a false. Then you say, if it is a weekday, but it's a holiday, well, you don't have to get up. If it's a weekday, but it's not a holiday, you do have to get up. If it's not a holiday and it's a weekend, do you have to get up? Go through those permutations and then output it. I know this is a bit tricky. Give it your best shot. Pause me now. Okay, how'd you get on? I'm going to start this one here. I'm going to say wday equals input. I'm going to ask the question first of all. Is it a weekday? And then we're going to want to say for the other one, which was like holiday, holes. Why don't we just steal some of that one there? Is it a holiday? And then I said we want to turn these into true or false. The only way of really doing that easily would be like if wday is equal to yes, then maybe we can start, we would declare a new variable here called weekday is equal to true. Okay. Else, weekday is equal to false. And then we can do the same here for holes. And we'll say holiday. And then say holiday here. Let me explain what I've just done here. All I've done is I have taken in the user's response, either Y or N for weekday or for holes. And then if they said yes for weekday, then weekday has been set to true. If they said, well, technically anything else, but in this case, N, weekday will be false. If holes is replied with a yes, that makes holiday true, otherwise holiday false. Now, let's think about it. Under what conditions could you stay in? If it was a weekend, you can stay in. if it's a weekday, but it's during the holidays, you can stay in. When do you need to have to get up? When it's a weekday and not a holiday. So if it's a weekday, so if that's true, and not holiday. Under those circumstances, you have to say print you have to get up. Otherwise, if you think about it, the other circumstances, if it's not a weekday, well, it's a weekend, so you can stay in. And if it is a holiday, well, then it doesn't matter if it's a weekday or a weekend. So in this case, we say else. So all the other situations, print you can sleep in. Fingers crossed. If we write it here, we need to test the one situation where it happens. So it is a weekday, but it's not a holiday. You have to get up. Okay, this one's over to you. I think this is probably a little bit tricky, but nowhere near impossible. Just take it step by step. The idea is you're going to mimic the system that will replicate how logic gates work. Remember, you learned about AND gates, and you learned about OR gates, and you learned about NOT gates. You ask the end user to either input 1 or 0 for input A or B. So you have to store input A as an int, and ask them to input 1 or 0, ask them to input B as either a 1 or 0. I do it as an int again. And then select, and then come up with a little menu and print out, please pick. Print 1 is AND, 2 is OR, 3 is NOT, and ask them to pick 1, 2, or 3. And then you see if they've inputted, for instance, they've said input A is 0, B is 0, and I've picked an AND, then you should say the output should be 0. This is going to be quite challenging with if and else statements and ORs and ANDs and combining things together, but you can totally do this. Or if they pick a NOT gate, you only use the first input, the input A. So if they've inputted A as 1, they inputted B as 0, it doesn't really matter because B won't be used, but they've picked the NOT gate, then you go, oh, A is 1, then the output would be 0. Okay, best of luck. Pause. Guys, if you got stuck, totally understand. I'm sure it's something where you can maybe drop into the comments, give me a shout, and maybe I'll come up with a solution for you to be able to use. See you in the next one.